Welcome back to part 2 of logarithmic functions. So we're going to go ahead and look at what the different logarithms look like, and I'm going to show you how to plug them into even a most basic calculator. So there are a couple properties, and you can see them there. We're not going to use them right away, but just put them in your list in case you have something that you need it for later. Right now what you need to realize is that a common logarithm is base 10, which makes sense because our number system is the base 10 number system, so that's what we call a common logarithm. And then a natural logarithm is base e. And so the ones that we've been messing with before that had the e and we switched it over, we actually will write that as a natural log. So here, excuse me, are some expressions. So this ln is how we write the natural log, so I'll write that here to remind us. And so what this is telling us is it's really a log base e. So this would be equivalent to writing log base e of 5. But because natural logarithms are so common, most of our calculators have an ln button on them. So what I just have in front of me is just a basic scientific calculator. It does have a natural log button and a log button, and if you see the log button, that is base 10. So what I'm going to go ahead and do is we're going to go ahead and plug this in. And so look on your calculator for an ln button, and so just turn it on. Now depending on your calculator, some of them you have to do the number first and then the log button, and mine is like that. So I have to push 5 and then hit natural log, and I get out approximately 1.61. So mess around with yours, see if you hit the 5 first before the natural log or the natural log before the 5. You might also have to hit a second or a control button before you do so. The next one is, notice there's nothing little down here as a subscript. When nothing is written there, that is a base 10. So that is a logarithm, a common logarithm. The logarithm button on your calculators, that is base 10, so we're not going to need to do anything. So on my calculator, I'm just going to do 78.143, then I'm going to hit the log button, and I get out approximately 1.89, right? So that makes sense because 10 to the first is 10, 10 to the second is 100, and 78 is closer to 100 than it is to 10, so it's closer to 2 than 1. Now this one is log base 8. Now log base 8 is not naturally on our calculators unless you have an Inspire or something higher level than that. And so what we're going to do is we're going to use what's called the change of base formula. And so how we're going to do that is we're going to write this as two separate logarithms. So we're going to take the logarithm of 691.45, so I'm just going to use a common logarithm, and I'm going to divide it by the log of 8. So I'm using base 10 for both of those, and by doing those, this is the change of base formula, it will find the answer for me. So the top one, 691.45, logarithm is approximately 2.84. Logarithm of 8 is approximately 0.90. So now I'm going to go ahead and do those. 2.84 divided by 0.9, and because I rounded, they're not going to be perfect. It's approximately 3.16. Okay, please do make sure you can put those into your calculator and get those answers out. If you have trouble, let me know what calculator you're using and I'll send you an email to help you out. Okay, the last thing we're going to do in this section is to graph. We're going to do it no different than we did with exponential functions. We're going to create a table and then plug those in. Do your numbers first so you know what to make your scale. So remember, h of x is the same as y. So I'm going to pick some x's and I'm going to see what I get out. So we're doing a base 2. Excuse me. So the idea here is we're going to take 2 to some powers, and that's going to give us a number. So let's do, I don't know, Well, let's just see what happens when we do 2, 1, 0, -1, -2. Now, because this is a base 2, when you go to plug it in your calculator, right, we're going to end up doing the change of base formula. So you're going to have to do log of 2 divided by log of 2. Well, this one's nice. Anything over itself is 1. Okay, I can do that one without a calculator. Now the next one, here I'll change color and see if that helps, is going to be log of 1 divided by log of 2. And the bottom 2 is because it's base 2. So log of 1 is 0. Log of 2 is 0.3. 0 divided by anything is 0. So it don't even matter what log of 2 is, it's going to give me 0. So now we're just going to go to the next one. So I have log of 0 divided by log of 2. So if I try and do 0 log, what that's saying is that 2 to some power is going to give me 0. Well, there is no way to get 0 if you multiply bases of 2. So it's going to give you an undefined or an error, which means I can't do it. Now, what do you think happens if I do -1? So if I try and do this one, log of -1 over log of 2, this is saying 2 to what power is a negative number. 2 to any power will always be a positive number, so again we're going to get error. So these are not parts of the equation or the graph, so all of this we can't do. So I'm going to need to have a number bigger than 2 because that's where it's growing. So let's try 4. So log of 4 divided by log of 2. So that is 0.6 approximately divided by 0.3. So that is 2, which makes sense because 2 squared is 4. Let's try 8. My guess is that it's going to be 3. Log of 8 over log of 2. So that's 0.9 divided by 0.3, and that's 3, because 2 to the third power is 8. So that's enough points for us to see what's going on. So I have 1, 0, 2, 1, 4, 2, and 8, 3. So I don't have huge numbers. So I'm just going to do kind of a basic normal graph. Everybody's just going to be in ones. Hopefully your lines are straighter than mine. So I have 2, 1. I have 1, 0. I have 4, 1, 2, 3, 4, 2, 5, 6, 7, 8, 3. Now, it's not that it stops here at 1. If I tried to, like, maybe let's plug in 0.2. So let's do log of 0.2 over log of 2. So I have -0.7 over 0.3. And so it's -2.3 approximately. So 0.2 is 1, 2, 0.3, it's about there. So what's happening is this is approaching the y-axis, but I'm never allowed to get there because there's no way I can get to 0. So there's my logarithmic graph. So that's the end of the third section. Go ahead and practice it. If you have any questions, let me know, and I'll get back to you. Have a good day.